Hello everyone, welcome to week 12 of Codivate Python class. This is our final week in this Python session and we're just going to be finishing up the tic-tac-toe game that we started last week. So, first things first, let's go over the homework from last class. The homework was to brainstorm a way to check if somebody has won in the tic-tac-toe game. Since this is a brainstorming problem, there's not just one way to do it. We're going to be going over a sample pseudocode. Pseudocode is just a sample of a plan, or just a plan that we can use to guide our code. It doesn't have to be written syntax in the language, but it's just a plan. It can be as specific or broad as we want it to be. So let's go over a sample solution for the pseudocode. If you want, now would be a good time to pause the video, just retrieve your pseudocode from last time, and see how it compares to this sample. Alright, so the first thing that we have is if at least 5 moves made. Why do we need to do this? And the reason is we don't want to check if somebody has won after every single move. We only want to check when necessary. So, when is it necessary? After how many moves? We know that somebody can't win after the first move or the second move because there's not enough pieces on the board yet. In that case, how many moves do we need? Well, the first time that a player can have 3 pieces on the board is after 5 moves. That's the point where player 1 can put 3 pieces on the board. It's not always likely that the game will be over in 5 moves, but it is possible, so our code has to account for that. Now we can start checking for win conditions. If at least 5 moves have been made, then we have to start checking each row and each column to see if somebody has 3 in a row. And how would we check this? So we have to use an if and an elif chain. We start off by checking the first row and seeing if 3 non-space items in the first row are in a row. So what this is basically checking is if we have 3 X's or 3 O's in the first row, that means somebody won. And if somebody won, we have to print the board as we have to do after every move. We have to print game over and then print that the current player won. This current player part is stored in a variable called current that we created last week. So we'd have to refer to that. And since somebody won, because there are 3 in a row, that means somebody won. That means we have to break out of the while loop since we are done with our gameplay. Now we have to use our elif. Once again, this you don't necessarily have to use the word elif in your pseudocode. This is just a plan after all. Now you'd have to check 3 non-space items in a row for the second row. So this basically means if we have 3 in a row for the second row. If that's the case, once again, we print the board, print game is over, and print that the current player won, and finally, we'd break out of the while loop because somebody won. At the bottom of this slide, you may be able to see 3 dots, and the reason we have that is because we're not done here. We have so many more win conditions to check, not just the first and second row, and we'll be breaking each one down in the next couple slides. Now that we have our plan, we need to implement it into our code. But before we do that, as I mentioned earlier, let's go over all the possible winning combinations. The first possible series of win combinations we have are horizontal winning combinations. If a player gets 3 X's or O's in a row horizontally. So we know that the keys in our dictionary represent each part of the board with these numbers. Well, technically strings, but we're just going to think of them as numbers. And at each number, there's going to be a piece. So at each key, there's a value, and each number, which is the key, there would be a value, which is the piece. In order to access those values, we'd have to use the dictionary syntax, but before we get to that, let's just think about which keys we would need to check. The first possible winning combination is if the top row has 3 in a row. So this would be checking keys 1, 2, and 3. Then we check keys 4, 5, and 6. Then keys 7, 8, and 9. That takes care of the horizontal winning combinations. Let's go over the vertical winning combinations. Our first combination is 1, 4, 7, then 2, 5, 8, and then finally 3, 6, 9. So once again, we'd be checking if the values at these keys are equal to each other and are not equal to the space. And if that's the case, that means we know somebody won. And specifically, it's the current player that won, which we store using the turn variable. Now let's go over the last winning combination possible, which is the category is diagonal winning combinations. The first combo we have 1, 5, and 9, and the second combo is 3, 5, and 7. These are all 8 of our winning combinations in tic-tac-toe, and we have to implement this into Python code now. Before we do that, let's just take a look at all the information we've gathered. We have all these lists of winning combinations, so basically the keys that have to be equal for somebody to have won, but these keys are also have to be non-space items. They have to be non-space items, and the reason for that is if there's 3 spaces in a row, that could happen at the beginning of the game because not every space is filled, and we don't want to make somebody win if there's 3 spaces in a row, because that just means there's 3 empty spaces on our tic-tac-toe board, and that doesn't really mean anything. So now would be a good time to pause the video, and using all of these winning combinations and the pseudocode, try to implement Python code that will check if somebody has won. I'm assuming you had a go at it, and now we're going to go over the solution. Our first step is to write the if count is greater than or equal to 5. As you may remember, the first part of our pseudocode was if at least 5 moves made, and in order to track how many moves have been made, we created a variable called count. You can call it anything you want. You can call it move underscore count if you think that helps you remember that it tracks moves a bit better. But in our case, we just called it count, and we're checking if the count is greater than or equal to 5. That's checking if at least 5 moves have been made. Then we can check all of our win conditions. The first win condition we have to check is the first row. We're doing that by accessing the values at the keys in the dictionary. So the first 3 keys we're looking at are 1, 2, and 3. Positions 1, 2, and 3 on the board are represented by these keys. And in order to access the values, we just have to use the name of the dictionary, square brackets, and inside the square brackets, our key is contained. If all of these values are equal at these corresponding keys inside our dictionary, and they're also not equal to a space. Once again, just a reminder about booleans. Double equal to are checking if 2 items are equal to each other, and not equal to is checking if 2 items are not equal to each other. So this takes care of our first condition. If 3 non-space items in a row for the first row are equal, then we know that somebody won. In that case, we still want to print the board because we want to display how the game is looking like after each move. And after that, we print game over, and using string concatenation, turn 1. Turn, as you may recall, is just storing the current player's name, whose turn it is. And once we are done with that, we break out of the while loop, because if somebody wins, we are done with the game, and we don't need to keep executing the gameplay loop over and over again. Then we have this elif here, this elif here, that will check for the next row. 4, 5, 6. It repeats the same process as above. We continue to do this with all these horizontal winning combinations. You can see 4, 5, 6, and 7, 8, 9. It would be a good idea to just copy and paste this code for each condition. And the reason why we use is copying and pasting. Is a simplified solution. It's pretty easy to understand what's going on and keeping track of all of our winning combinations. If you want to make this more efficient, you can try to think of ways to do that. You can maybe think of writing a loop to check for all of these conditions. You might have to do some casting between integers and strings because the keys are actually strings. Or you could also, another way you can make this more efficient is by taking these three lines, which are you can see appear often many times after each elif and each if. You could try to make them all into one function and then use that function over and over again. So we use fewer lines of code, but this solution that we have here is pretty easy to understand, so we have kept it in this format. Now we just repeat the process for vertical win conditions. As you can see here, these next three will take care of vertical win conditions, and this is in the same indentation as the previous elifs. We continue with the same process and do the same thing for the diagonal win conditions, 159, 357, and that will take care of checking for all win conditions. But there's one more way that the game could end. If we've checked for all the win conditions, now we have to look for one more thing, ties. How do we check if there's a tie? If you want, now would be a good time to pause the video, maybe think about another way to do it besides the solution here, and just come back and just review the solution here. So we could use the count variable and then just check if it's equal to 9. One thing that we should note is that this takes place after our if-elif chain. And why is that important? If we've checked for our entire if-elif chain, that means we know that, and we make it to the end without breaking, that means we know that nobody has won on the current move. So if we're in the middle of the game, that's completely fine. If nobody has won yet, we still have moves to go. But if we're at the end of the game and nobody has won yet, then we know that there's a tie. And in that case, we have to check for the end of the game by using count is equal to 9. Since there's 9 spaces on the tic-tac-toe board, and if we've made 9 moves, that means the board is completely full. And since we're checking for this after the if-elif chain, this also means that nobody has won. This means that there's a tie. And in that case, we'd print the board as usual just to show the filled board. And then we'd print game over, it's a tie. Just a reminder, these \n characters are just escape characters, and they're just printing a new line just for clarity. Nothing fancy here, just escape characters for formatting. And since there's a tie, we know the game is over, and we break out of our entire gameplay loop. Our last part of the game is changing turns. Now would be a good idea to possibly pause the video and plan some ideas for this one. And now let's go over the solution. I'm assuming you paused it and how to go at it. In this case, we can just use a simple if-else statement to change the turns. If the turn variable is equal to player 1, that means we know that the current player is turn. And at the end of the turn, we should change the turn variable to player 2. Then we can change their piece, which should currently be X since it's player 1's turn, to O, that is player 2's piece. This would take place at the end of checking for everything because only after checking for our win conditions we should change turns, since if somebody's already won, there's no point in changing turns and continuing to play on. But after each turn, we should change these variables, since they keep track of whose turn it is, and we don't want to come up with a huge entire if statement for 2 different players' turns, but instead we can just make the process more efficient by using variables like this. So that takes care of the first case. If it's player one's turn and the turn is finished, once again this code is taking place at the end of the turn, then we just swap the turn and the piece. Else, this else lines up with this if. This else means that it's player two's turn because there's only two players. Tic-tac-toe is a two-player game. That means it's player two's turn, and we should switch the turn and the piece to player one and player one's piece, which is X. Now that we have pretty much finished our entire game, now would be a good time to maybe just pause the video, go to your game, make sure it works, and you can run the game once. So we have one more task to do. If you want to restart game currently, if you want to restart our tic-tac-toe game, we could obviously press the run button, but it would be more convenient if we could just restart directly through typing something in the console like I want to restart. And the reason why we made our gameplay all inside one function is because it would be easier to restart. If we have our gameplay function as a function, then we can just ask the user if they want to play again, and if they want to play again, we could just call the game function instead of retyping or copying and pasting our entire gameplay code twice. So we start off, obviously, our entire code by just playing the game because we're assuming that the user opened this program because they wanted to play tic-tac-toe. Then we have this while true loop. So let's take a look at what happens inside here. Once the user has played the game once and we're finished, they get asked, do you want to play again? If they answer yes, we clear the board and play the game again. And in that case, we're done. So we go back to the top of the loop, and after the game is done, we ask them, do they want to play again? If yes, they will play again, and we go back to the top of the loop, and you can see the process will repeat. However, let's say after maybe 3 times of playing the game, they're back at this point. Do you want to play again? And maybe they're done, they're tired of playing, so they answered no. In this case, if their answer is no, we'd say okay bye and break out of the loop. Since we broke out of the loop, the user doesn't get asked, do you want to play again? And we're just done with our entire program. Else, if they enter something besides yes or no, then we should tell them that I could not understand what you were saying and ask them to enter again. And we don't need to do anything specific to ask them to enter again. We just have to remember not to put a break here so that our loop will loop back to the top and ask them again. The only time that we need to use our break keyword is if the user says no. Otherwise, there's a chance that they want to play again, so we have to remember not to keep a break so our loop can just loop back to the top and ask them if they want to play again. This is the implementation for the restart code. This just takes all the pseudocode, once again we have pseudocode here, and implements it into actual Python code. Our first step is to just play the game normally. That's a game function here, we're just calling it. Now is this inside this while true loop is the entire process for playing again. We're going to create a variable called play again, and it's going to be assigned some input. This user input, we're just asking the user for their answer to this question. Do you want to play again? Just to make the process easier for us, we're going to have the user enter just Y or N instead of yes or no. So let's say they enter Y. How would we check for that? We would use an if statement. If play again, which is being stored by this entire user input, just a reminder, whatever the user answers will be stored to this variable called play again. If a lowercase version of that variable is equal to lowercase y, we're using this just in case maybe the user enters, let's say, uppercase Y. They still mean yes, but maybe they just have caps lock on or something. So we want to just understand that as well. This was converted to lowercase, so case doesn't matter, and check for the lowercase y. If you want, you could also make this play again dot upper is equal to uppercase y. It's up to you. Doesn't really make a difference. And if this their answer is y for yes, we know that we have to do a couple of things. We have to clear the board, because if a player wants to restart the game, we can't just obviously have them play in a filled board. We have to clear the board and then play the game. We know the play game part, which is just calling the game function that will play our game. But how would we clear the board? We would loop through each key in the board and assign the corresponding value at that key a blank space. Because, as you may recall, at the beginning of our entire tic-tac-toe program, we created a dictionary called board and assigned it a bunch of keys, and all the values were empty spaces, and they were representing each position on the tic-tac-toe board. At the beginning, since there were spaces, we need to reset all of them to spaces if we want to play again. Now we do an elif to check if their answer was no, and for no. If they answer no, we know they're done with playing. We just print, okay, thanks for playing, bye. Nice happy message there. And we break out of our code. Because we're done, and the user doesn't want to play again. If they want to play again, maybe some other time, they can always come back to our REPL.it page and run the code. Else, which is our final case, let's say they don't enter Y or N, then we know that the user entered something else. Maybe they made a typo, accidentally clicked something. So we just have to let them know that we don't understand what they're saying, and we want a Y or an N. We're just going to use a bit of string concatenation to let them know that, sorry, I don't understand what you said, and whatever they entered is stored in this play again variable. So we could just put that here, sorry, I don't understand whatever they entered, which is inside play again, and we would ask them to please enter Y or N, which is what we are looking for in these if-elif statements here. So, always a good idea to test our code. Let's open it up in our REPL.it file. Let's move this over there. And let's just go over the code really quickly. Just generally, we have our board, storing each position in the tic-tac-toe board. We have our demonstration function, shows how the board looks like. We have our print board function, just prints the board at any point in the game. We have our game function. You can see the introduction part of the game, the initialization of the variables, the actual gameplay inside our while loop, checking for win conditions, checking for a tie, and then finally we're changing turns. Outside of our game function, we have the actual code that will be executed. We're calling the game function, so it runs whatever is inside. Then, starting at this while true, you can see we have all of our restart code implemented, and we are ready to play. So I'm just going to make the console a bit bigger so you can see it. And let's just run a sample game. Let's say the first player's name is student1, and the second player's name is student2. So now we get this message here. Now that our pieces are set, let's see how to play. When it is your turn, select a number between 1 and 9 to move. The board below shows where your piece will appear depending on the number you choose. So we can see this kind of key here for our board. Now let's get started. Student 1, where do you want to move? Always it's a good idea to test our code, so we'll test a couple of things out. Let's say we enter something like we want to enter 5, but we type it out as a word. We get invalid input, and we're asked once again to enter a number from 1 to 9. Student 1, where do you want to move? You can see that it works correctly because it asks the same student to move again. Now we type in the number correctly. You can see it'll put our piece in the correct position. Now we could move for student 2. Let's say they want to move in this corner. Now it's student one's turn. Let's say they want to move in this corner. And we could keep playing. Try to prevent tic-tac-toe. And then just entering the numbers as we go. As you can see, in this case, it'll turn out to be a tie. So we get the correct message. It's a tie. Do you want to play again? Um, let's say we are done. Then it'll tell us, okay, thanks for playing. Bye. There's a lot more tests you can do. You can test uh, if player 1 wins, if player 2 wins, if player 1 makes 5 invalid moves in a row, just anything that you think will make sure that your code is working. You can try it out. You could also try out different things for this replay option here. All sorts of things. Uppercase Y, lowercase y, typing out yes, typing out no. So that's basically our tic-tac-toe game. If you want, just to see this output, you can compare your tic-tac-toe game with how this plays out. Just make sure it plays out in a similar way, or if you want to make additions and upgrades, that's also up to you. We'll discuss that a bit more now. Alright, so there's some extension activities for this tic-tac-toe game. Since there's no official homework, this is the last class. You can try some of these things on your own just to make your tic-tac-toe game more advanced. You can add a computer player, and you can think about how you would use variables and logic to create a computer player that would know how to play tic-tac-toe. Once you get that working, you can add more levels of difficulty. Maybe instead of using strategy, the computer player that would add an easy level would just randomly choose a position. Another feature you can add is counters to keep track of how many games each player has won. Or what you could do is maybe even let players choose a piece besides X or just O. Maybe they want to play tic-tac-toe with maybe their initials. Then you'd also have to check if their initials are the same. Because in that case, then it would be very confusing if both players were using the same piece. And there's just a whole lot of things you can do if you kept going with this basic program for tic-tac-toe and then extend it to add various improvements, and not just in terms of coding efficiency, but just adding features. And you can let your creativity run wild with this game. So there's more extension activities. You can obviously look at different versions of tic-tac-toe. Ultimate tic-tac-toe kind of looks like this. You can see it kind of looks like a Sudoku board, but we're playing tic-tac-toe with tic-tac-toe boards. You can see whoever wins a game gets their piece on that board, and then they have to try to get 3 in a row on the big board. And there's a lot of things you could do. You could just look up tic-tac-toe variants and do some research on Wikipedia. So the tools that you've learned in this class will help you with trying to implement those things in your game. You can also look at 3D tic-tac-toe. Right now we have a 2-dimensional board. Maybe we could have a 3-dimensional board that would have 27 spaces. You can do anything you want with this base program that we've went over how to create in Python, and then just anything we've learned up to this point. If you want to just continue your programming practice and keep sharp on your Python skills, here are a couple of resources. There's Codivate. You can look up codivate.com/Python. You could look at Free Code Camp. They have some introductory Python review videos. There's also practicepython.org, which has some programming problems. Codivate has a lot of function writing, which is very important in Python. So I would definitely recommend taking a look at that and just going over some of the problems there as a good review for this class. If you want, now would be a good time to pause the video, maybe write down the links, and then maybe later you could look them up in your free time, and then just go over those. So, Now that class is over, I just want to take a moment to say bye and good luck on any programming endeavor you choose to take on in the future. It was a pleasure teaching through these video lessons, and I hope this class was meaningful, you enjoyed it, and you learned something new. So bye, and good luck.